Okay, so let's take a look at another form that you can come up against. What I have here is repeated linear terms. So because it's the same linear term repeated, it's squared, I know that I can say that 2x minus 3 over x minus 1 squared is equal to a over x minus 1 plus b over x minus 1 squared. Now if I multiply through by x minus 1 squared, it's going to cancel here, leave me an x minus 1 up here. So what I'll get is 2x minus 3 equals a times x minus 1 plus b. Okay, so let's go ahead and let x equal 1. I want that because it's going to make this component right here equal to 0, which leaves me just my b. And when I do, I get 2 minus 3 is a negative 1. So I get negative 1 equals b, or obviously, therefore, we say that b equals a negative 1. Now, if I come back and I need to let x equal some other number, 2 or 0, let's make it 0. So if I let x equal 0, then what I end up with is negative 3 is equal to a negative a plus b, which is minus 1. So if I add 1, I'll end up with b equal to a negative 2. Oops. That's not b. I'm talking about a. And it's a negative a. Really jumped out ahead of myself there. I have a negative a. If I add 1 to both sides equals a negative 2, that means that a is equal to 2. So now I have my two coefficients. So now if I integrate this, I have the integral of 2 over x minus 1 plus, with a negative 1, so I'm going to make it negative. Rather than 1 over x minus 1 squared, I'm going to write this as x minus 1 to negative 2 dx. That way I can just jump in there and do the integral. So this is going to be equal to 2 ln x minus 1 minus, this is going to be x minus 1 to the negative 1 divided by negative 1. So the negatives are going to cancel. That becomes a positive plus c. So my solution is simply going to be 2 ln absolute value x minus 1 plus 1 over x minus 1 plus c.